It's a pleasant time to learn something. So, today our topic is applied hydraulics and pneumatics. So, hydraulics is a fluid, we can call it as fluid, that is hydraulics. So, whether we are need to know something about hydraulics, we have to know the properties. That's why we can apply in certain cases. So, so what are the properties of fluids? We have discussed such things. So, first one is specific density. So, specific density or specific mass or mass density is the mass per volume of the fluid. It's denoted by rho is equal to mass per volume. So, unit for mass is kg. So, volume is meter cube. So, kg per meter cube. With increase in temperature of fluid increases and hence mass density decreases. In case of fluid, as pressure increases, volume decreases and hence mass density increases. This is the concept of density. Next to density is specific weight. Specific weight or weight density of a fluid is a weight per unit volume. So it's denoted by W is equal to weight per volume. So weight is unit for weight is Newton. So volume remains the same, meter cube. So Newton per meter cube is the unit for specific weight. With increase in temperature, volume increase and hence specific weight decreases. With increase in pressure, volume decreases and hence specific weight increases. Therefore, specific weight is equal to specific density into acceleration due to gravity. So specific density is rho into acceleration due to gravity, that is g, 9.81 meter per second square. Then specific volume, it is a volume per unit mass of fluid. So specific volume we can specify v suffix s, that is a specific volume, that is equal to volume per mass, that is equal to meter cube per kg. So volume denoted by meter cube and mass denoted by kg. So meter cube per kg is the unit for specific volume. Actually, it's a reciprocal of density or mass density or specific density. So specific gravity, it is the ratio of density of fluid to the density of standard fluid. So we can also call it as relative density. So this is the explanation for specific gravity. So that is equal to, so fluid divided by standard fluid. It's a dimensionless unit quantity. Why we call this dimensionless quantity means both standard fluid as well as fluid we use in that concept is both of them having same units. So for each of them cancel together. So there is no unit for specific gravity or relative density. Next to the specific gravity, we should know pressure. Pressure of a fluid is the force per unit area of the fluid. In other words, it's the ratio of force on a fluid to area of the fluid held perpendicular to the direction of force. That is, pressure is equal to force per area. Unit for force is Newton. Then unit for area is meter square. So Newton per meter square is the value for pressure. We can also call it as Pascal. So Pascal is equal to Newton per meter square. So it's denoted by capital P. Then viscosity. So viscosity is a measure of hydraulic fluid's resistance to flow. It is hydraulic fluid's most important characteristic and a significant impact on the operation of system. When hydraulic oil is too thin, flow viscosity, it does not seal sufficiently. This leads to leakage and wear of parts. When hydraulic oil is too thick, the fluid will be more difficult to pump through the system and may reduce operating efficiency. So this is the viscosity. Then you have two things, that is dynamic or absolute viscosity. Absolute viscosity is equal to coefficient of absolute viscosity is the measure of internal resistance. So dynamic viscosity, it's specified by Newton second per meter square. Then kinematic viscosity. So kinematic viscosity is the ratio of absolute or dynamic viscosity to density of a fluid. The kinematic viscosity can be obtained by dividing the absolute viscosity of a fluid with the fluid mass density. That is dynamic viscosity divided by density. So meter square per second. This is the unit for this. Then compressibility. Compressibility is defined as the ratio of change in volume to change in pressure. It's denoted by letter B. For fluids, compressibility depends on either the adiabatic or isothermal process. Then bulk modulus. So bulk modulus is defined as the ratio between increased pressure and decreased volume of the material. It is denoted by the letter K. Oxidation stability. The oxidation is caused by the chemical reaction between the oxygen of the dissolved air and the fuel or oil. The oxidation of the oil creates impurities like sludge, insoluble gum, and soluble acid product. The soluble acidic products can cause corrosion, and insoluble products make the operation sluggish. Then demulsibility. The ability of the hydraulic fluid to separate rapidly from moisture and successfully resist emulsification is known as demulsibility. If oil emulsifies with water, the emission will promote the destruction of lubricating value and sealant properties. Highly refined oils are basically water resistant by nature. Lubricity. The wear results increase the clearance, which leads to all sorts of operational difficulties, including fall of efficiency. At the time of selecting hydraulic oil, care must be taken to select one which will be able to lubricate the moving parts efficiently. Rust prevention. The moisture entering into the hydraulic system with the air causes the parts made from ferrous material to rust. The rust, if passed through the pumps and valves, may scratch the nicely polished surfaces. Pour point. The temperature at which oil will clot is referred as pour point. Flash point and fire point. The temperature at which liquid gives off vapor in sufficient quantity to ignite. Momentarily, when flame is approached, is called flash point. A minimum temperature at which hydraulic fluid will catch fire and continue burning is called the fire point. Neutralization number, the number of acidity or alkalinity of hydraulic fluid, also referred as pH value of a fluid. High acidity causes oxidation rate to increase rapidly. Pump. A pump is a mechanical device that is used to pick up water from low pressure level to high pressure level. Basically, the pump is a device which converts mechanical energy into hydraulic energy. The pump operates on the principle whereby partial vacuum is created at the pump inlet due to internal operation of the pump. As the piston is pulled to the left, a partial vacuum generated and allows atmospheric pressure into the fluid. the pump via reservoir valve. When the piston is pushed to the right, the fluid movement closes the inlet valve and opens outlet valve. The quantity of fluid displaced by piston is ejected out the discharging line leading to the hydraulic system. Pump classification. There are two broad classification of pumps: dynamics pumps, non-positive displacement pumps, positive displacement pumps, then dynamic pumps, generally used for low pressure, high volume flow applications, not capable of withstanding high pressure, that is limited to 250 to 300 psi. Actually, psi means pound force square inch. Primarily used for transporting fluid from one location to another. Positive displacement pumps ejects a fixed quantity of amount of fluid. So this is the advantages: small and compact in size, greater flexibility of performance. So this is the categorization. So pump categorized into dynamic pump, positive displacement pump, from which dynamic pump, centrifugal pump and axial flow pumps. Then the positive displacement pump categorized into gear, vane, piston pumps. The gear pump is categorized into externally internal lobe and screw pump. So vane pump, fixed displacement, variable displacement pump. Then piston pump, fixed displacement, variable displacement pump. So these are the things.